Right, a few announcements first. Your lab number 2 was posted yesterday. It's going to be due. Check your wiki, right? So just check the due date over there, okay? For lab number 1, if you're still struggling, please come for help, all right? My office hour today or Friday, 3 to 5 p.m. That'll be the best, right? All right, that's about a quick announcement. Now, I want to start with this particular exercise with you together very quickly. And then that's the last topic we talked about last time, just about short circuit, okay? Very quickly. And for the rest of the IFO syntax and common error, I'll rely on you to study them. Just go over them. You know, it's very easy to go through. And then we might refer to some of them later. Okay, let's consider a different example over here. Let's say we're trying to define this withdraw command. Let's say we got an account, which is an array of accounts. Let's say for the account class, we have attributes called balance, for example, or query, okay? Which is going to tell you what the balance is for the account. And then we say that we want to do some withdraw with some amount, integer, okay? We want to say we want to withdraw from this particular index in the array. For example, you might have an array over here, right? And then each one of them is pointing to some account objects. We say we want to do specifically to this particular index, change the account over here such that the balance is going to be decremented because of withdrawal, right? That's kind of the command we're trying to implement, okay? Let's not worry about the amount being not too large and also being non-negative. Let's say we checked that already. Let's focus on something more, okay? Now, let's consider the require I write over here, right? I'm kind of mixing IFO and Java a little bit for a reason, okay? Pretend that everything's IFO except I'm using ampersand over here, right? That's the kind of what you learn from Java, right? Now, the term that we briefly mentioned last time is called short circuit, right? This will illustrate very nicely how short circuit works, okay? Now, can anybody judge and tell me whether this precondition here is okay? Okay? Do you think it is always not going to be okay, or maybe only under certain circumstances it is not going to be okay? Yeah, go ahead. Yes. You can still get an index out of bound exception. How? Yep. Okay. Now, that's kind of the issue you have to also look into, right? Very carefully. Okay, let me just show you what the issue is. Okay, about short circuit evaluation. You can definitely refer to the slides. Okay, so-called short circuit evaluation. So this is how it works. If we got a series of conjunction over here, this is how it works. We're going to evaluate from left to right, which means we're going to evaluate this condition first. Let me call it C1, condition 1. And then we're going to evaluate C2. And then we might also evaluate C3. This is going to be the order, C1, and then C2, and then C3, okay? And the short circuit effect tells us the following. We know that logically speaking, for conjunction, the result will only be true if all the operands are true, right? As long as one of them is false, there's no way for that to be true anyway, right? So here's the idea at the runtime. As we are going to do C1, and then C2, and then C3, okay? Let's say, for example, if C1 already evaluates to false, which means somehow I is actually less than lower, which means it's too small, the index, right? That means it's going to be false. In that case, we're not going to bother evaluating C2 and C3, right? Now, if we consider this original example, you can see that the main thing really is C3, which is really about the I index not being too large, right? We're saying that should be smaller than or equal to accounts the upper. We're only checking C3 after we have used I, C2. So the order over here is not really right, given that it's going to be C1 followed by C2 and C3, right? So now, to be more concrete, let's say over here, let's talk about this particular array. By the way, for IFO array, you can definitely use lower and upper for the minimum index and the maximum index. In IFO, array indices don't necessarily start with 0. You can start with any indices, typically 1, typically. Okay, that's something you also want to pay attention to. Okay, Let's say we talk about this particular rate. Let's say 1, 2, 3, 4, 5, and 6. Let's say we got 6 indices that can be valid, right? So now let's say for the input over here, let's say for I, we simply pass 7. Okay, let's say we do that, right? And we know that lower would be 1, the minimum index, and upper would be 6. Okay, lower would be 1, and upper here would be 6. Okay, so now let's try to evaluate this. Okay, let me use purple here. Okay, if you try to evaluate this condition over here, it's basically accounts that lower, which is 1, less than or equal to I, which is 7. This would be true, not a problem. If it is true, that means we should bother to evaluate the rest unless you hit false for conjunction, right? So now, however, you can see that 7 will definitely make this predicate over here also false, but it's not going to be evaluated just yet, because now it's the term for this particular evaluation over here, right? And now, what would that be? That basically is accounts at position 7. The balance larger than the amount. In this case, 7 is not a valid index, right? It's off the bound. So it's going to be contra violation, like index out of bound, contra violation, something like that. Okay? So now this is the issue. You kind of place the condition to be checked for conjunction in the wrong order. And you have this kind of issue here because the short circuit effects. Okay? Now, to say a little bit more, okay, and then we don't have to spend too much time on this. Basically, what I want to say, I will summarize what I want to say here, and then let's talk about fix quickly. Logically speaking, P and Q and R should be the same as, equivalent to, P and R and Q. We know that, right? Commutativity. However, in programming, especially when you got short circuit effects, okay? In that case, P and Q and R not necessarily equivalent to, I mean, talk about runtime behavior, not necessarily. P and R and Q. And here, of course, we simply use ampersand, 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 and ampersand, ampersand. Okay, that's a summary of what we have covered so far. Okay, let's talk about the previous one. Now, how do we fix this one here? C1, C2, C3, individually speaking, they're okay. But now how do we change them so that it's going to work? Swap the order, right? So rather than checking C1 and C2 and C3, we can say C1 and C3 and C2. Okay, that's a fix. It's a very popular exam question. Okay, so it's early, but I'm telling you, it could be there. Okay, okay. So now fix would be, you want to say C1 and C3 and C2. I'm just saying the order of evaluation does matter for the case of short circuit. So that means short circuit operator is kind of like a logical conjunction, but not exactly, okay, because order matters. So now, how is this relevant to our context for IFO? Let me just summarize that quickly for you. So now for IFO, interestingly, they support something that will work just like logic. They also support something that works like ampersand, ampersand in Java. Okay? In IFO, if you want to have something like a short circuit, you can say and then. If you say P and then Q, this is completely equivalent to ampersand, ampersand in Java, and then. Okay? And similarly, if you want to see what's the correspondence for vertical bar in Java, right? It will be P or else Q. Okay? The same. Also the short circuit effects. Now, what about the interesting bit is something that doesn't really exist in Java or the C family language. Again, it's a design choice for the IFO language. I just want to bring to your attention. So now you can definitely have another operator. And interestingly, if you say P and Q without a then, that simply means you're going to evaluate P and Q, even if you already know P is already false. So you evaluate both operands. So this corresponds to just the conjunction you have in math. Even if you know P is already false, you will still evaluate Q, even if. Okay? Even if P is false, you will still evaluate Q. Okay? No short No short circuit effects, basically. Okay, and what about the correspondence for disjunction? For disjunction in IFO, you can just say or, rather than or else. Okay, it's a very quick summary about these operators. Okay, how does that affect you? I would say usually just use and then or else. Okay, usually. Yes? You mean if you only use and rather than and then? Yes, then you will have index out of bound exception. So you see, the way we use it, let me just go back to the Java one very quickly, right? So that means over here, the way to write this in IFO, I do encourage you to try. What you should do is you should say C1 and then C3 and then C2. That's how you should write it in IFO. Because and then will have the short circuit effects, which means if we know already C3 is false, we wouldn't bother to evaluate C2. However, if you take out the then, it's going to evaluate no matter what, right? Yes? What would be the benefit to use without a short circuit? That one is more like you want to say, logically speaking, I want to make sure I evaluate both. Yeah. But I would say since in some way we are trying to write some design that is executable, it's also like a programming. So using and then always is fine. Okay. I'm just trying to highlight an interesting difference to you over here. Okay. Okay. Now that's about the short circuit over here. Okay. And then we can talk about some interesting design. Okay. Okay. For today and Monday, my ultimate goal is to somehow prepare you well for two things. Number one, I want to prepare you all for lab number 2 because you're supposed to write some contracts, okay, especially post-condition. Number 2, more importantly, after the reading week, you're going to have your lab tests 1 and 2. One of them will be about writing contracts, one of them. So that's why I want to give you this lecture earlier so you can think through the issues, okay? And this definitely has no, maybe you haven't seen this before, so it's going to be very interesting. We're going to talk about exactly how you can write complete post-condition. That's the ultimate goal. But today I'll try to give you some background and prepare you well for that. So eventually when you see the stuff written down in IFO syntax, it wouldn't be a shock to you. Okay? There are many things you had to understand for background. But we'll start very smoothly. Yes? Yeah. Okay, for array in IFO. Okay, let me just change to iPad. Give me one moment. Okay, for array in IFO. So let's say if I declare A to be array of, let's say, string. Again, I'm just going to sketch the idea. You can definitely try in using IFO Studio. If I simply say creates A dot make empty. If I only say that, right? That one is simply going to create an array, just like how you visualize it in Java. Okay? A is going to point to some reference for the array, but now the indices, by default, they start with 1. Okay? Just 1 over here. Of course, initially it's empty, right? But let me just put a little bit more stuff here to actually show you. Okay? And now how can you add stuff into the array? You can refer to the syntax slides. One way to do it, you can say a.force. Okay, and then I can force a string, let's say called A. So which position do I want to force it into? Let's say I want to force it into exactly where the upper, well, let me just write it down and I'll explain to you. It's a little bit tricky over here. Okay, it's a very standard way of writing things, okay? And then let me do another one. A.force B. And then A dot upper plus 1. Force simply means if the index you're writing right now is invalid, they can create that, they will grow the array dynamically for you. Okay? So the the index over there does not have to be valid. Does not have to be. Okay? Let me just show you exactly how it works. So now, after this line over here, okay, we talk about A dot lower, A dot upper, right? So A dot lower and A dot upper. From how you understood from Java programming, A dot lower should be 0, right? That's kind of their lower indices, right? But in IFO, it's not, okay? Lower would be 1. Okay, lower will be 1. And now what will be upper? Let me try to lead you to think backwards. The way to think about lower and upper is in this way. Okay, you can think about the range of indices is more like a closed interval, which we talked about last time, right? Closed interval. You can think about a dot lower and between a dot lower and a dot upper. The number of indices in this closed interval here tells you the size of the array, right? For example, if I tell you this, let's say the lower for the array, let me just make some concrete example. Let's say 1, 2, 3, 4, 5, 6. In this case, the lower is 1, the upper is 6. And what should be the size of the array? 6, and how do we figure? 6 minus 1 plus 1, right? That's something we did last time. So now let's think a little bit backwards, given that that's the case. So always, to actually calculate the size of the interval, you can say a dot upper minus a dot lower plus 1. That's how we calculate the size. Now, initially for an empty array, if I tell you a dot lower is 1, what should be a dot upper? 0. Good. Thank you. Okay. Hopefully you can just do the reasoning over there. That's the initial case for empty array. So now this will lead very naturally to why are we writing this line over here? When we say initially, let me just use a different color here. So A is basically pointing to some empty array. Okay, I'll just say empty here, just empty range of indices. When I say A dot force and then A dot upper plus 1 should be 1. Is this correct? 0 plus 1, that'll be 1. That means I'm forcing an element to index 1 of the array. So after this line, it's going to grow dynamically index 1 over here and then with A. So now A dot upper after this line becomes 1. And A dot lower still is 1. It doesn't change. Okay, let's do one more line. And then A dot force over here, and then we still got A dot upper plus 1. In this case, A dot upper plus 1 would be 1 plus 1, which would be 2, right? We're growing the array again, 1 by 1 basically, right? It will be 2. And then we just have B over here. So after this line, A dot lower is still 1. A dot upper has just become 2. It's a very standard way of writing things. Okay, one more tip for you. You might be asking me, so how do I have an array that start with 0? If you're more comfortable with it, nothing wrong with that. You can look into a feature over there in the array. If you look up the API for the array, there's a feature called rebase. Well, literally simply means rebase to the system for indices 0. I wouldn't mind if you actually try to go there, but be careful. Because sometimes maybe in the lab test or in the exam or in whatever assignment, we might explicitly tell you, for now, this case, assume indices will start with 1, in which case you should not do rebase, right? But if we didn't constrain you on this, you can do anything you like, as long as it works. Yeah? A dot force C100. Okay. I tell you what, if you say, let's say after this line, I'll answer very briefly, but you can try it out, okay? If you say A dot force C, and then you just put a very large number, okay? Basically, you're trying to create an element over here with index 100, and then put C here, right? Now the question is, what should you put over here, okay? What a compiler will do will be, they will look at what's the type over here, and every type should have some default value. In this case, for string, maybe the default value is simply just empty string. They will just put empty string in between. Okay, that one I would say this is not a very common usage for the force, so you don't have to worry too much about it. Okay, yeah, guys, any question about the this? That one's kind of extra. I didn't plan for that, but since you asked, so I can answer that quickly. Yeah. No, you don't have to. You know what? You can double check for me. I haven't really looked at API for a while. I believe the typical usage for array is you can just start with empty and then can keep forcing into the array like how I did. Or if you simply don't want to do that because it's inefficient, right? You can just use a linked list, for which you can also start empty and then keep extending to the list.
But how would you compare with the maximum value, like the maximum number of elements you want to reach? So let's say you want to have 6 elements.
Yeah, I believe maybe you know what? Let me look it up, and I don't remember exactly. I think there might be a constructor in the array class where you can say, I want to start with index 1 and index 7 initially, right? Yeah, let me look it up. Okay, I don't want to give you the wrong information. Okay, so now, okay, hopefully that will be helpful, maybe for your projects, I guess, maybe later. Okay, now for this lecture here, today we're mainly just going to talk about reference versus expanded type. For those of you who read a little bit about IFO 101, so you have seen the word expanded already, right? And also we're going to talk about different copies, which we also talk about in 2030, but maybe with a little bit more depth, because the way you do the copy, either reference copy, shallow copy, or deep copy, is going to affect how your contrast may mean. Okay? That's why we talk about it first before we talk about postcondition. Let's do in a steady pace. Okay, let's talk more about the modeling point of view. Okay? For those of you who took 2030 before, right? We have the notion between aggregation versus composition, right? The way I put it is to say aggregation simply means you can share objects. For composition, that means the object itself is an integral part of some other objects. It's not shared. Okay, that's kind of the very brief characterization. So now let's see one example over here, and then we'll see how we can do that syntactically. Okay. So now let's say so integral parts. So that's okay. So whenever we talk about expanded, that means you want to do composition, which means the objects that you're going to create at the runtime, it's not going to be shared. Okay, we will see more examples. Okay, so now it's not going to be shared. Let's see one example here. Let's say this example here. Let's say talk about your prison lab. Okay, each workstation has its own CPU, monitor, and keyboard, and they share the same network. You can see some parts are basically composition. For example, CPU, monitor, and keyboard. Though no two workstations share the same keyboard, for example, right? And also the network should be shared, right? They all belong to the EECS network. So now let's just see, visually speaking, how do you draw that quickly? And then, so that means from the modeling point of view, you should at least know such distinction. And when you try to implement a design, you should know what to use. Okay, let's have a look at the diagram. Let me show you the diagram over here. Okay, that's a diagram. Let's go over that quickly. Let's say you got 3 workstation objects. Okay, so let's say this is workstation number 1. Okay, workstation number 1, workstation number 2, and workstation number 3. Okay, you can see for each one of them, they have an attributes called network. Okay, you can see that this part here is actually shared, which means every workstation has their network part pointing to some common object over here, which is the EECS network. That one's sharing. On the other hand, you can see, for example, let's say W1, W2, and W3. W1.k is different from W2.k, right? They're different. Okay, they're different objects. Are we okay? Okay, it's only from the modeling point of view. But now, let's think about how you will achieve this in Java. What you have to do is to somehow implement something called a copy constructor, right? And then to ensure the copy constructor is really ensuring there's no sharing, right? That's what you would do in Java. However, in IFO, again, it's a language design choice. They allow you to only introduce a keyword called expended so that you can achieve such modeling concept. Okay? So in some way, this concept is not exactly new. I'm just saying it's a shortcut to do it. Okay? It's more like a doing composition. Okay? Let's just see how it works. It's quite straightforward. Just introduce you to some syntax. You can ask me questions. Okay, so now let's compare 2 fragments of code. So they are really achieving the same purpose. Okay, let's see how exactly they can be used. So now let's talk about, okay, basically we're trying to translate this particular design into some implementation over here, right? So now one thing to note, okay, let's see this. So first of all, we are trying to declare a class, 3 classes basically. And we got keyboard, we got monitor, we got also CPU, and also we got network. So these 4 classes are exactly declared the same way, okay? So they are simply just a normal reference class, nothing expanded just yet, okay? Now, if you look at another class over here called workstation, right? You can think about workstation. We're defining a template for each workstation objects. And now, if you look at that, let's look at the network first. This one is something you're familiar with. We say n is of type network, which means at runtime, n is going to store the address of some network objects, right? That's what reference type really means. You know that pretty well from the previous courses. Now, what about K, C, and N? K, C, and N over here. So keyboard is a normal reference type. And we are trying to turn that into an expanded type by writing expanded at the front. Okay, it's a modifier, basically. Okay, so now that means if you combine these two things together, that means K cannot be shared. Okay, and similarly for CPU, since it's an extended CPU, also it's an expanded monitor, so they cannot be shared. So that would just correspond to exactly this diagram over here, right? Because the keyboard is not shared, CPU is not shared, and monitor is not shared either. Okay? Guys, any questions for the first version? First version is very nice. Let me just finish something. The first version is very nice, which means when you declare the class, you don't have to say at the class level, the class itself is expanded. You only do the expanded when you try to declare the variable to say, I got this reference type, for example, keyboard, I want to make it expanded for this particular scenario. That's version number 1. It's more flexible. Yes, question?
No, actually,
Oh, good, okay. Now for version number 2. Version number 2, maybe when you first create a class, you just want to make it expanded. That's the only usage, okay? So now when you let's have a look at this. So now you can see we do have expanded, but now this time, the modifier expanded is applied at a class level, which means at the runtime, if you try to create an object of type keyboard, that object there can never be shared. Okay, we'll see example, but I'll just say that verbally first. Yes?
what do you mean by can't be shared?
Well, we'll see that. We'll see that in a moment. You know what? Cannot be shared in the sense that, remember we talked about the concept called aliasing in 2030, right? Aliasing simply means you may have two reference variables that are pointing to the same objects. You cannot have two variables that point to the same expanded objects. That's what I mean. You cannot share. But we'll see exactly how that goes. Yeah. I'll give you a simplest example to illustrate in the next slide. Okay, and then over here you can see this, since we declare CPU also as expanded, also monitor as expanded, so now when we declare the attributes over here, we don't have to say expanded again. Okay, but both versions achieve the same thing. Which version should you go? Up to you. Okay. Guys, any questions about this? Okay. Yeah. No, nothing about access control. When we declare the class to be expanded, it simply means at the runtime, if you try to try to instantiate a class, whatever that's being instantiated cannot be shared. Let's see an example. Maybe you still have doubts. You can ask me again. Okay. All right, let's see example here. Okay. Now let's look at the simplest example together. Okay, now let's look at the left-hand side. We are having an expanded class, okay? And then it's called B. And then we have a command called change I because we have a attribute here, I, integer, okay? And then we say to some new integer, and then I is assigned to ni. Very simple, okay? Like a counter in some way. Any question about the expanded class over here? It's very easy, right? The only thing that may not be so clear to you yet is how the expanded keyword we added here is going to affect the runtime. That's exactly what we're going to see. Okay. Now, I want you to look at the fragment of code over here. Okay. Tell me something. Pretend temporarily I get rid of expanded over here. Presume, hypothetically. Let's say there's no expanded here. So everything should be familiar to you. Do you think this piece of code test expanded or test, doesn't matter. Do you think the right-hand side piece of code is going to compile without expanded? I'll give you hints. Void safety. Void safety simply means you should not have null pointer exception at the runtime. And the typical cause of problem for a null pointer exception is you're trying to call a method on a void object or null object, right? Now, this code here, let's say without expanded, is it going to compile? Okay, good. Okay. Now, can you tell me which line is not going to compile?
Top two. Line 5.
Line 5, okay, because? Yeah, exactly. Exactly. You can see that this is the very first line for the implementation here. We are trying to say EBI is a context object, and we are trying to query about I. But EBI, if it was not expanded, it's not even being created yet, right? So it might be void. Okay, so this actually highlights something that's very fundamental between expanded type versus reference type. Okay, for expanded type, it will be initialized automatically. Okay, so now, how are they initialized? Let me just mention that to you. Okay, so now, for now, let me put back this guy here. Okay, let's say it's not expanded. Okay, and this code is going to compile because it's expanded. Okay, now, basically, this is what's going to happen at the runtime. At the runtime, as soon as we are having these two declarations over here, EB1 and EB2, and they have type B, and B was declared as expanded, right? Even before the first line of the execution, okay, even before the first line, before line 5, we are already going to, at the runtime, it's something that will be done automatically. They are simply just going to create two objects, EB1 and EB2. Okay, I'm going to call it EB1 here and EB2. And then the way they do this is by looking at what attributes you have in this particular class, and then simply give them the default value for every attribute. In this case, we only EB1, we also only got a I attributes, and default value will just be 0. And also I here, it will just be 0. That's the automatic creation of expanded type objects that will be done. So that is why this code will just compile. Void safety is not an issue because the creation of objects is just automatic. Okay. Are we okay for this? Okay. That is why you will see that over here, when I say something like this, when I say result is assigned to, right, EB1, which is over here, the I would be 0, yes. EB2, which is over here, the I would be 0, that's also true. So this will just give me true, right? So when I say check result n, we'll just pass, right? Oh, by the way, check result n is something that we did in the tutorial, right, for the bank account, how to use ES test. Okay, I assume you have watched that already. If you haven't, you got two choices. You can either ask me later or watch the tutorial, all right? Make sure you are comfortable with that. Okay, so now for the next line. Line number 7. This one's interesting, okay? Line number 7. When I say EB1 equals EB2, okay? Now, the equal sign here, I can, equal sign is like a comparison, right? So what we learned before, we say, if you say EB1 equals EB2, what are we comparing really? Let's say back in Java a little bit. Okay? We are not really comparing the contents, but we're comparing the addresses, right? If they point to the same objects. From intuitively, if I simply say EB1 equals EB2, should it be false or true? False, right? They seem to be different objects over here, right? However, according to the test I'm running, it's actually going to be true. It's based on value, okay? Now, it's context dependence, the equality sign here. That's why I want to illustrate this to you. So now, let me just write it here. When you are trying to do things like this, let's say when you have object 1 equals object 2, okay, in iPhone, okay? It depends on what the type is for object 1 and object 2. If they are both reference type, yes, you're comparing addresses, okay? Let me write it down. If the object 1 and object 2, they are reference type, then you're trying to compare addresses, right? Okay. On the other hand, if you're trying to say, if object 1 and object 2, let's say in this case, EB1 and EB2, they are not reference type because they were instantiated from expanded class. So they should be comparing just the values for their attributes. Okay, in that case, okay, I'll put a second case over here. If object 1 and object 2, they are expanded type, okay, expanded type, so that means you're going to compare, I'll say contents, a little bit vague. But in this case, you're just going to compare the value for their attributes, which means 0 equals 0, yeah, so that'll be true. So this is really comparing contents. In that case, it's going to be true, okay? And there's another difference between expanded type and reference type, right? Now, let's do another one here. The next one, pink, orange, let's say. Now, if I do line number 9, okay, like that. If I do EB2.change I, so now how many objects are being changed? Just one, right? Because it's context objects. In this case, we're talking about EB2. When I say EB2, which is a context object over here, change I, which is going to change whatever I it is, right? So modify that to be 15. So EB1.I is unaffected, right? They are independent objects. They are not going to be shared, okay? That one is also not too bad. Okay, so now that's why you can see EB1.I would be 0 over here. EB2.I will be 15. Okay, that's what makes sense. Now, let's now do another one. This one here, 12. So now, result is assigned to EB1 not equal to EB2. True or false? True because they are different objects, or because their attributes are different? Because their attributes are different, right? It's very important to know, okay? Even though they are different objects, that's true, but it's irrelevant to the equal sign here, right? Not equal to, okay, basically you're comparing EB1.I versus EB2.I, okay? Check this out here. Yes?
So why is it because they're different values again? I thought their types are reference types. They're going to be comparing.
No, the EB1, EB2 over here, okay, maybe you missed the details in the beginning. So you can see over here, EB1 and EB2, they're of type B, right? Remember, B is expanded. That means what you learned about reference type before does not really apply. It's a different concept over here, right? Again, the reason that we have expanded type is have a convenient way of doing composition. For which case, you got to manually encode using copy constructor in Java. That's why. Okay. Yes?
That's the pronunciation that the auto gives default values.
Yeah.
So is that only for expanded type?
It's only for expanded type, yes. I would say in principle, yes. I would say in this early stage, I would say you can imagine that for reference type, you should always initialize them explicitly using constructor. And then for expanded type, they are going to be initialized right away, implicitly. We will see some interesting application for expanded type later when we talk about singleton pattern, which you did maybe previously in 2030. But if not, we're going to talk about it. Okay. Yes?
So let's say you want to compare objects in expanded type. How do you do that?
If you want to compare objects in expanded type, you know what? I better check this on the compiler. You know what? You're basically saying this. Let's say, I tell you what, it may not even compile, because let's say this. Let's say we have, let me put this down, and then I can find out the answer exactly for you, but at least we know what the question is. So let's say I got class B over here, and, okay, I got some attribute over here, and then let's say we got some tester code. You're basically asking the following. Let's say I got local over here. Let's say I got v1, variable 1, of type B, which is reference type. I got another variable over here, and then it is expanded B, for example, right? Expanded version. Okay, you're asking if I try to do the following, if I say v1 equals v2, now, does it really mean reference comparison or context comparison? I tell you what my intuition is, but I'll double check for you and then let you know the answer. My intuition is this should not compile. Because you're trying to compare basically expanded version versus reference version, right? I'll find it out and I'll let you know. I'll put a question here, but you can think about it, right? I'll come back here and let you know on Monday. I'll try it out at iPro Studio, okay? Yes?
Can you explain it to a class
Good question. I think can the expanded class have several constructors? The answer is definitely you can have several constructors. My understanding is it is simply just going to initialize every attribute for you rather than calling a particular constructor. There might be a way to tune in to say you want to call this particular one, but you don't have to worry about it. Okay, so all you got to know about expanded type, at least the minimum extent, just to know that it's different from reference type, and there'll be no sharing. Okay, guys, are we okay? Okay, you're right. Let's go back here. Okay, that's exactly what I have just gone through. Okay, that's the example we just did. Okay, let's just go over some rules very quickly. Okay, so now every variable or entity must be declared to be either reference type or expanded type. Okay, either expanded or reference. Oh, if you look at the integer class, for example, the integer class itself, maybe you never noticed, just go there and check. The integer class is an expanded class. Okay, which means if you got integer value, it's analogous to integer int type in Java. In Java, you got int versus capital integer, right? It's a little bit like that. Int type is called primitive type, which cannot be shared. It's not reference type, right? It's a little bit like that. Okay, good. Let's now go back to the slide here. For reference type, okay, so whenever you talk about reference type variable, it denotes the reference to some objects, right? We're going to talk about reference type for sure when we talk about copy. When you say assignments over here, it's going to copy just the reference. So this is where the aliasing can occur. We'll talk about aliasing throughout the lecture, so don't worry. I just want to briefly mention that, okay? And then when you say x equals y, it really compares references, the addresses. On the other hand, for expanded type, as we just have seen, y denotes, okay, here, it does not denote reference. It denotes the object itself. That is why the way I draw them was a little bit different, right? You can see EB1 is directly the name for the objects over here. If it was a reference type, this is how I would draw. I would say EB1 is more like a pointer pointing to some objects over here. That would be a reference type drawing. Okay, I just have some minor detail. You will see lots of things like this when we talk about copy, okay, reference copy. Okay, so now, okay, expanded type, and when you do the copy over here, this is an interesting bit. Since we know there's no sharing over here, so when you say y is assigned to x, basically what you're doing is like this, okay, which I didn't have over here in the example. Okay, it's a bit messy here. Let me say this. No, I don't want to delete it. Oops, add a page below. Okay, over here, the same block of code. Oh, thank you. Yo. So you didn't say the ugly part, so it's already done. Okay. Okay, so now, again, let's say, again, from the previous drawing, what we got is EB1 over here. I'll show you quickly. The last value was 0, right? And then we got EB2, and then remember from that particular line, we changed that I to be 15, right? Let's add one more line to the code, okay? And then we'll illustrate to you. Oh, sorry, that's too big. Oops. That's I here, and then that's 15. Okay, let's add one more line. Let's say over here, if I say EB1 is assigned to EB2, okay? They are not reference type, which means we are not really changing around the pointers. Do you want to take a guess what it is going to do? Yeah, we're going to somehow change EB1, right? How do we change it exactly? I agree with you because EB1 happens on the left-hand side of the assignment. We're going to change it somehow. But how do we change it? There's no references over here, right? Okay, it's easy. Basically, what it's going to do, well, again, the runtime system does this for you automatically. You just have to be aware. This is what they will do. They will go over every attributes for this particular class. For I, for example, they will do basically EB1.I is assigned to EB2.I for you. That's what they will do. After this, there's no sharing still, right? EB1 is still independent from EB2. They only do some copy over here for you, okay? At the runtime, it will copy attribute by attributes for you. Yes?
What happened to get which was a reference type?
It's a very interesting question. The question was, what if an attribute of reference type In that case, they will copy the reference for the attributes. In which case, you do have some aliasing not at the top level there, but at the second level. Okay. Basically, what I was asking is like this. Okay, I'll draw the visualize for you. Okay, it's a good question. I was expecting that actually. That's a very natural question to ask. I was just too lazy to mention that in the slides. Here. Okay, let's say we do have a reference type over here. Let's say over here. Let's say we got R, and then for example, let's say person, for example, right? Oh, actually P person. Oh, sorry about that. You know what? I'll make it better. Can you better? Is it better? Like that? Okay, good. Okay, so now let's say we add a attribute P. Let's say P over here, and also we got also attribute P, right? Let's say at the moment, let me just do from scratch. Okay, let's say before that, we got basically over here 0 and 15, right? Okay, and then what we got, let's say P. Okay, let's say EB1.P is pointing to this particular person object. Okay, I'll just draw like a box. And EB2.P is pointing to another person object. Okay, so now let's see again how the things are going to work. If you look at the pink line again, EB1 is assigned to EB2. EB1 and EB2, they are expanded type, which means it's going to copy attribute by attribute for you. It's as if you write the following lines. You're trying to say EB1 dot I is assigned to EB2 dot I, and also in that case we know pretty well it's just going to put like this, right? As we saw. Another line would be EB1 dot P is assigned to EB2 dot P. What would this do? Well, basically it's not going to create any person object, right? So now, rather than pointing to over here, EB1.P is now going to point to wherever EB2.P is pointing to. That's the consequence. Okay? Again, you don't have to do any of this. It will be done for you at the runtime. Okay? Good. Okay, so now let's see what the next thing is. Okay, very, very quick exercise for you. Okay? So now let's think in this way. Okay, let's read the problem together. Every published book has an author. Every author may publish more than one book. Okay, should the author field or attributes of a book be reference type or expanded type? Yes. And give me some rationale. Why would you think that should be either reference type or expanded type?
I think it should be a reference.
You think it should be reference type? Why?
So every published book can have pointing to an output, but each output is its own object.
Yes. Which means, okay, I'm going to show you the diagram. So what you're suggesting, one solution here, you're saying that, let's say I publish 2 books. That means those 2 books, their author field should both refer to me as the author field, right? Which means if I change my name, their author field should be changed automatically at the same time. That's good. That's about sharing. What about if you want to model another scenario? Let's say you got 2 physical books. You got OSC2, you got the, actually what's, Touch of Class, right? You got OSC2, you got Touch of Class, right? Okay, it's these 2 books. That you do have the author information somewhere around, maybe let's say cover page of the book. Let's say if I modify the author field of one book, is it going to modify the author field for the other book, the physical copy? Not really, right? So in this scenario, you may want to make them expanded, which means either you're talking about the record itself in the database, in that case, it may have to be shared. If you talk about the information that's on the physical book, the physical copy, it may not be shared. Again, it depends on what you need, really. That's my point. There's no standard answer. Yes?
But how many times will you actually change the author of a single book, though, right?
Well, I'm just
Cases there are.
Yeah, you know, for example, let's say maybe the author information contains the, for example, the name, the nationality, many information over there, right?
Right.
Whenever they change, do you have to go to a single place to change the object that's being shared, or should you change the multiple places, right? It's a modeling problem, really.
Yeah.
But I would say author is just one particular example. It can be other things, right? Okay, any questions before I show you some diagram? Okay, let's see this one very quickly. I do want to mention this one design principle that's interesting to see in this particular case, okay? Okay, so we got two cases over here, right? Hopefully that's very obvious to you. So I'm saying both are justifiable, depend on what you need. For this particular case, you can see for this particular author, it's an author record object. Let's say it's a SQL table in your SQL database, right? So that means as soon as I modify, let's say the name for this author, for example, to be Jackie, for example, I only need to modify only one place. And then when I say this book, author's name, Jackie, and this book, author's name, also Jackie, only modify one place. On the other hand, if I go to the expanded type version over here, right? So now, how many times do I have to modify? Well, 2 times, right? It's kind of obvious to you, right? Modify here to be my name, right? But again, what exactly you need is depends on your application, okay? So now I want to say one more thing, okay? Which we'll touch upon many times. I want to talk about this solution specifically, okay? This one here, okay? Let me just wipe it out again. You can see that the good thing about this particular solution is it satisfies the so-called single choice principle. Okay, I'll mention that and then I'll just give you some intuition. We're going to visit that many times. So now it's called single choice principle. In fact, if you took a 2030 with me, maybe either last semester or last year, I did mention this briefly when we talk about inheritance. Okay, single choice principle means the following. Whenever you want to make a change to your software, there should be typically only one single place you have to change. If you have to go to multiple places to modify such information, that implies you got duplicates in your design, or your design smells. Okay, that's how I call that, right? Okay, so now in this case, you can see in the reference type solution over here, it does satisfy the single choice principle, because if I want to modify any field of the author, I can go to the single place over there and modify that, for example, whatever I like, right? Once I modify that, that's the only place I have to go. On the other hand, for the second solution over here, of course, if that corresponds to how your application works, by all means, you should really choose that. Okay, but that one doesn't really satisfy the single choice principle, because I need to modify here, also here as well. Okay. Okay, single choice principle, we'll revisit that for many times, so I just want to give you first exposure to it. Okay, so now, after this, that's about the expanded type. You know, again, expanded type is just a modeling concept about composition without any sharing, okay? Okay, so now let's go back to reference type, where things can be interesting, okay? We're going to talk about copying objects, okay? I'm hoping to at least go over, you know, we do have about 25 minutes. Let's see how much we can do. What we're doing right now is going to prepare you to write complete post condition. In order to write complete post condition, you have to master the usage of the old keyword in IFO. To do that, you have to know exactly how IFO implements the old keyword for you under the hood. And it's really about how you copy objects. Okay, so what I will do for today, I will give you the distinction between 3 kinds of copy: reference copy, shallow copy, and deep copy. Okay, we'll do hopefully 2 examples, and then we'll go there on Monday to see how we can use them. Okay, in writing post conditions, right? This is indeed something you just cannot do easily in Java, but the contract that you can actually specify by using copies is extremely powerful. Okay, and again, it can be very good for design, for writing contracts. Okay, excuse me. Now for copy objects, okay. So now let's make some assumption over here. Let's say we got a class called C, and okay, let's see this. Let's say this is kind of the diagram we have, okay? Let's say we have 2 objects, C1 and C2, okay? And then we got, okay, of the same type and only one attribute A, and A can be any type, okay? The reason I put a cloud over here is because A can be as simple as of type integer, or A can be as complicated as a red black tree, like what you did in lab number 1, right? So I'm just trying to say the attribute A here can be of any type you like, just in general. Okay, so that's kind of the layout we want to have. I want to show you intuitively how the different copies might work visually, and then we'll use example to show you. That's more relevant to writing postcondition. Okay, so now we're going to see the first example, reference copy. I tell you what, that's the easiest way. That's the easiest case. Basically, whenever you want to do a reference copy, basically just saying C1 is assigned to C2. That's what you do, okay? And what changes? Do we have to modify A over here? Not really, right? Basically, we're saying C1, rather than pointing to here, is going to point to wherever C2 is pointing to, right? And now we got aliasing. Why do we have aliasing? If I now do some comparison, if I say C1 equals, by the way, this is not assignment anymore, right? It's equality, right? C1 equals C2, and C1 dot A equals C2 dot A, 1 and 2. What should be the result for 1? True, simply because if you try to visualize it for you, C1 pointing to this object, C2 pointing to this object as well. They're the same pointer, right? So that should be true. Very good. Now, what about number 2? It's basically almost like a no-brainer, right? Because we know that C1 and C2, they're not referring to the same objects. You're basically comparing the attribute for the same objects. See what I mean? Okay? So now, when you try to, we can still try to do that. So now, when you try to do, let's say, C1.A, you basically follow this pointer over here, C1.A. You're talking about this particular field, which refer to this cloud, right? And then, if you try another one, let me use blue maybe. If you do C2.A, again, C2, because of aliasing, is pointing to the same object, .A, is also going to point to the same cloud. So we are really referring to the same cloud. Right. So that should be true. Okay, very easy for reference copy. Okay, I tell you what, reference copy is very easy at the runtime to implement because you just copy address. However, everything comes with a cost. Something that's easy to implement may not be so powerful for you to use to specify contracts. That's something we'll see. Okay, but let's just distinguish between different cases for the copy. Case number 2, shallow copy. Okay, syntactically, I'm not sure if you have used that so far, but you definitely use either shallow copy, reference copy, or deep copy for lab 2. Okay, so now what you got to do is when I say C1, okay, again we say it's assigned to something. Now rather than just saying C2, I say C2 dot twin. Make a twin, basically. Okay. So what does it really mean to make a twin? Okay. So it's a shallow copy. And we also say shallow copy is more like a first level copy. Okay. But I'll illustrate that to you. Shallow copy is slightly more expensive than reference copy to implement. Let's see exactly how that works. Okay, again, we still got C1, we got C2. Okay, let's now break it down into 2 stages. How do we know what C2 the twin is? Okay, C2 the twin. Basically, C2 the twin is going to be, basically, we're going to create a new object first. We're going to create a new object over here. Okay, it's going to be of type C. Also with an attributes A over here, C2 the twin. Okay, so now we are creating new objects for sure. That is different from the original object, which is C2, right? It's different objects. Okay, and now what we're doing is, what about the attribute A? Attribute A is already the first level, basically the first level for the attributes. Now, how do we do the copy here? We do reference copy for the first level. That means rather than duplicating the cloud, we are simply saying, well, C1 dot, oh, you know what? Let me make it a little bit easier for you. Let's say we call this C2 underscore twin. Okay, let me just call that. Okay, it's a kind of invisible variable. So now, basically, after you create this object here, you would say C2 underscore twin is assigned to dot A is assigned to C2 dot A. That's basically what you're doing over here. And conceptually, you can think about A is just going to refer to the same cloud. No new cloud is being duplicated, right? And now, when we do this particular, so that's only C2 twin. Okay, that's only for your understanding over here. I'll just keep that. And then when we do this assignment over here, so C1, rather than pointing to the original objects, is now going to point to this particular new twin that we just made, right? Okay, now let's do the same comparison. We used to compare C1, C2, and C1.A, C2.A, right? So now if I say C1 equals C2 versus C1.A equals C2.A, what's going to be, the result is going to be different, right? What about 1? False. Okay, thank you. Because, let's visualize it. Because now over here you can see C1 is pointing to this object over here. C2 is pointing to this object, right? Different objects. Good. What about number 2? True. Okay. Because over here you can see that C1.A is pointing to here and referring to this particular cow over here. And then over here C2.A is referring to here, which is referring to this the same cloud. So that will be true. Okay. Hopefully you see that. Okay. It's really important to realize we do have aliasing starting from the first level. Okay, for the twin. Okay, you can see especially number 2. You can see that the true over there tells you there's some aliasing over there. But for number 1, there's no aliasing because we're creating a new object. Okay. Any question about twin? Okay, still fine, right? Okay. Now, for next one is going to be a deep copy, which means we're going to go extreme, which means we're going to copy everything, so that C1 and C2 they're going to become something completely different, even though it's a copy. Okay. So now what we'll see is first of all you should know how to write a syntax over here. C2 dot deep twin. Okay, deep twin. Deep underscore twin. Okay. Now let's see how we draw the objects. Okay. The first step to create a deep twin is just the same as how you do a twin. The same. Create a new object first. What you will do is first of all you will create a new object over here. Let me, for convenience, let's say C2 underscore dt for deep twin. Okay. It's now create a new object over here of type C. And now, for A, exactly how do we do it? Well, basically, if you simply point to the same cloud as C2.A, it's just shallow copy, right? Just twin. But now since we call it deep twin, this is what's going to happen, visually speaking. And then I'll tell you what it means in the program. Basically, what we're going to do here is we're going to make a copy of the cloud and then point to there. And somehow you can think about this is kind of the copy made from C2.A. And the way you implement the deep twin is just recursive. What does that mean? That means the following. So you can think about C2 dt dot A is assigned to, you can see what we did previously is simply just C2.A, right? Using reference assignment. That's what we did previously for shallow copy. But now what we can say is assigned to C2.A dot deep twin. Under the hood is how it is working, which means we just recursively copy the object structure until we reach the base case. That's what you would do. That is why what you will get is you got a completely identical cloud, even though it's a different cloud. Right? It's different objects, but it's the same structure. So now let's try this one over here. If I say C1 equals C2, and also C1.A equals C2.A. All right? Over here. Now, let's say it's a reference type. Just make it simpler for you. Okay, just a reference type. Everything is reference type. So now when I say, what about 1? Would that be true or false? False, right? Good, good, good. Because we're talking about different object, you know? So we want to draw it. So, oh, actually, I forgot to show you. So now that means C1, rather than pointing to here, is now going to point to this particular deep twin over here, right? So now that means over here, C1 is pointing to here, C2 is pointing to here. Yeah, that's false. Good. Different objects. So now, what about the second one? Also false, right? Good. Sorry. Okay, that should be 2. So that means we're simply referring to different cloud over here. This is one cloud. Sorry, not cloud. This is one cloud. This is the other cloud. Okay. Okay. So that's only an example to show you the idea about having reference copy, shallow copy, and deep copy. And we're going to need another example to help us to get closer to writing postcondition. We're preparing you for that. Any question about making copies here, conceptually? We okay? Okay. So now, let's now go to some more concrete example rather than just symbolic. Okay? Oh, actually, there's another example I want to show you quickly to compare the different copies over here. By the way, this is actually a diagram from OOSC2, the textbook. Okay, they also have some nice explanation there. You can also refer to it if you like. But I want to show you quickly how you can read this diagram. Basically, let's say, pay attention to 2 objects over here. Okay, I'll highlight it for you. Okay, so let's say, first of all, we got B here. B is pointing to this particular object over here. Okay, now, when we say B and A is at the moment, oh, you know what? It's easy. You know what? I'll present it this way. I think that'll be less confusing. Okay, let's start with this. Let's start with A, the right-hand side. So A is pointing to this particular object over here. Okay, that's A. And now, what does it really mean when we try to make a reference copy, say B is assigned to A? Well, that means B is just going to point to the object, right? It's the easiest way the cheapest way to do it, right? So that means B is just going to point to the same objects as A. Okay, that's a reference copy. Okay, now, what about a twin? Okay, so we still got A there, but what about A dot twin? So now what we're going to do is you're going to see that, first of all, we're going to create a new object over there. Okay, let me just say this is a new object, the first step. We're creating new objects over here, and then eventually C will point to it eventually. Okay, what about the first level attributes? As we said before, for the shallow copy, we're going to do reference copy for every attribute, right? The second step. That means over here, I'll give you one example here. Can we just say over here, I'll give you some, okay, here. You can see for this object, we got name, we got landlord, we got loved one, right, over here. So now, for example, you can see C dot, let's say name. Let me just say landlord. I think that's what the diagram is showing. C dot landlord, this is landlord. Is assigned to which objects? A dot landlord, right? I'll show you that. A dot landlord. Okay, let me show you the aliasing over here. Okay, C dot landlord is basically over here, and then so where is A dot landlord? Can you see from the diagram what's A dot landlord? Itself. So they're pointing to the same objects. All right? Because we know that A dot landlord is pointing to this particular object. That is why when we do this particular copy over here, C dot landlord is just going to point to exactly the same objects, which is A itself. Okay, that's a shallow copy. I'll just show you the landlord case. You can also try to see the case for also the loved one. Okay, you can do that similarly. Okay, one more thing to show. What about deep copy? Over here, what you have is, let's say, deep copy. So if you say A dot deep twin, so that means eventually what you will have is this. So let me just first identify where D is. Let me use a different color here. Let's say D is pointing to this particular person object over here, right? You can see the landlord is pointing to itself, and also the loved one is pointing to some object over here. So that you can see that whatever below this line is the object structure for the deep twin, which has nothing to do with the object structure for A. That's above this line. They're completely independent, right? That's why whenever you do deep copy, you're creating something that's completely recursively independent from the original one. Okay? This diagram actually illustrates quite nice things. It's just not as formal as what I just showed you. Okay? Hopefully that makes sense. Any questions about this diagram here? Yes?
How do you get those loops from here? If we do like, shouldn't we make a separate object? Because if we have like a loop going from, let's say, Almaviva to Susanna,
It's a good question. You know what? It might be nice to try out for this one here. Let's say, yeah, I see what your concern is. I see what your concern is. I think conceptually that's what the author for OOAC2 intends to show. You're basically mirroring the original object structure, right? To say over here, because we have this, it is landlord is pointing to just itself. You're saying that since it's pointing to some object, so this should be a separate object as well for deep twin. It might be nice to try this out to see exactly how it works. Yeah, I agree with you. Yeah, that's a good question. Yeah, but you know, I would say conceptually, at least the bottom line, whatever structure you're creating over here should have nothing to do, no aliasing between the object structure here. That's the bottom line. Okay. Yeah. I actually agree with you. Maybe most likely the object structure may not be exactly what the runtime will do. Maybe what you're saying is right. Yeah. Do you think you can reproduce it quickly and show it to me on Friday? No, no worries. Okay. No pressure. If you can try, that'll be nice. Yes.
But you have aliasing like b is equal to a, like on the first one.
Yeah.
Because they're both pointing to the same object.
Yeah.
If I was to make a change, say like a dot landlord
Yep.
is like x.
Yep, yeah, yeah.
B dot landlord would also be x.
Correct. Correct. So what you're saying? Yeah, that's exactly right. What your observation was, in the first case, after we assign A to B, after this, we know that B and A pointing to the same objects, right? You're basically saying, let's say we change the landlord for A. Let's say A.landlord is currently pointing to A itself. Let's say we change that. It is now going to point to some other person object over here, right? Is it going to change B.landlord at the same time? The answer is yes, because B is now pointing to the same object over here. And when you say landlord, is of course is going to point to that same object as well. Yes, it will change at the same time. For shallow copy, you know what? Let me save this a little bit. For shallow copy, you know what? It's a very nice question you have. They will make a transition to the next example I'm going to give. When you make a shallow copy of the objects, there's something that can be observable if that's only at the first level. If something that happens beyond the first level, it is something that cannot be observable. But what do I really mean by observable? That's something I'm going to show you. Okay? Yeah.
And deep copy this never happens.
Yeah, for deep copy, whatever you do on the original copy, it's just not going to affect the deep copy, right? That's true.
Because it's its own object. It
Correct.
shares the initial state.
Correct. That's correct. Yes. All right. So now at least I can start you. We got 5 minutes. At least I can start the first one. Okay. So we get an idea, and then we can finish the rest and then go to post condition next time. So now, okay, let me just go a little bit slides with you. Okay. So we are very much ahead of. No, everything has been talked about. Right. Everything has been talked about here. Okay, so now I would like to now draw another example here. This now is much closer to what you're going to write for post condition. We talk about array. Okay, so now let's make the following assumption. Okay, again. So if any variable is declared type is a reference type, that means it's an address. Okay, just some reminder. So this is what we're going to try to compare. Okay. Again, I'm going to show you the 3 different cases for reference copy, shallow copy, and deep copy. And then we'll try to make some changes on the copy we make. Depending on what kind of changes we have, it may or may not be observable to the original objects. Okay, that's something we're going to get into. Okay, but at least we can show something. Okay, it'll just take 3 or 4 minutes. At least we can do something. Let's say there's a reason I chose imp versus old imp. There's a reason for that. Okay, you can think about imp is more like the implementation that we're trying to modify. Old imp is more like an old copy. for which we can compare. Remember, we talk about post-condition, you should always try to draw a relation between the old and new version for the attributes, right? So, but now we're just trying to do this manually, okay, just to get your intuition, okay? But we'll get there. So let's say we got imp, we got old imp. Let's say we simply, that's the exact syntax you can write, right? Imp.make empty, right? What I just mentioned. And then let's say we got also force 1, 2, and 3, Alan, Mark, and Tom. Okay, so now, are you happy with this diagram here? And I'm going to redraw it, okay? Let's say imp is basically pointing to some array objects over here, which has 3 elements. Imp at position 1, so indices start with 1, okay? Imp at position 1 is pointing to an object, string objects. By the way, string is not expended. String is reference type, okay? So now, so you can see that this is pointing to Alan, and the second index is pointing to Mark, and third index is pointing to Tom, okay? Now, for the old imp, I put a question mark over here, simply means we can do the old imp by different kinds of copy from imp. We may either do a reference copy, shallow copy, or deep copy, okay? So what I would suggest, at least we finish a reference copy today, okay? At least, I hope. We'll see. So now let's go over this code. We're going to have many versions of this very similar code to illustrate the difference. Let's just go over the very first version very carefully. So let's say I simply say old imp is assigned to imp. It's a reference copy, right? I'll draw some diagrams with you together, but let's do that a little bit later. Line number 2, I simply say result is assigned to old imp equals imp. Should that be true or false? They point to the same object, right? Should be true. I'll draw the diagram. Okay, it's there, good. And now, if I say imp2 is assigned to Jim, all right? And I do the following across. Okay, that's also a good case study for you to see how to use the across. You can see that I say go over every position for the imp array. I want to see it. Oh, by the way, tilde is how you compare string values. I'll talk about tilde maybe next time to give you some tip. So now here I say imp j.item is the same value as old imp j.item, right? Can you see after the lines for 4, 5, 6, and 7, should the result be assigned to true or false? Okay? Well, let's see. Basically, we are trying to make some change to the new imp. We want to see if that will affect the old imp. Okay? The result is true. Okay? Let's see exactly how that happens. That's the same block of code. So now let's see over here. So when we say old imp is assigned to imp, that means we got old imp over here that is pointing to exactly the same object over here, right? That's how we got aliasing. So now when we say imp at position 2 is assigned to Jim, we're basically saying imp is over here at position 2 is assigned to Jim, right? Well, to be more precise, I tell you what, to be more precise, rather than pointing to the objects called Mark, we are really trying to point to a new string objects over here, and then it's for Jim. Okay, so now let's do the across very quickly, and then we're done. So now let's see exactly how line number 4 to line number 7 will be executed, right? So now, how many iterations are we going to have for these across? 3 iterations, right? Good. So the j.item is going to be 1 or 2 or 3. Okay? When it is 1 and 1, when we say imp at position 1, we're referring to this object over here, and old imp at position 1, referring to the same objects, right? Right? Old imp is over here, which is referring to the same object. So they should be equal trivially. Okay? What about iteration number 2? The same idea, right? Because imp 1 and old imp, they're simply alias to each other. Right? In that case, imp at position 2 is referring to this object over here. Old imp at position 2 is referring to the same object. Of course, they are equal. Okay, one more. Okay, and then what about here? So now, third iteration. Imp at position 3 is referring to, oh, I circled something wrong. I'm sorry about that. When we talk about position 2, it should be this one here. Okay, the new objects. Beg your pardon. Okay, yeah. Let me just get rid of that. Okay, the same idea. So now for iteration 3, what we're going to have is imp at position 3 is referring to this object over here. Old imp at position 3 is also referring to this object. So they are equal, trivially. This example is very easy. I tell you what, for next Monday, what we're going to do is like this. I'm going to modify line number 1 to either twin or deep twin. And then for line number 3, I might do some different changes. We want to see if the same across loop from 5, 6, and 7 will change. That will illustrate the difference between the two copies. Okay, I'll see you Monday.